Yes, dear viewers, you're welcome to another session of mathematics factorization, part of algebra. We are moving slowly by slowly. Previously, we talked about factoring by grouping, or what we call factorization by grouping. Then we have moved a step to what we call factorization by difference of two squares. This is a very, very important topic for all of you who are taking mathematics at a local curriculum, mostly grade 1 students, grade 2 students, grade 3 students, up to grade 4, because this is an examinable, subject. Then also people who are on international curriculum, that is Cambridge, IGCSE, Year 7, Year 8, Year 9, and Year 10. You need this topic which I've come to introduce today. So, factorization by difference of two squares. This is part of mathematics which now makes a real mathematician. So if you don't know what we call difference of two squares and its applications, then you are not yet in the lane of mathematicians. So in mathematics, once we have this, or in algebra, we know very well, we know that a squared minus b squared is what we call a difference of two squares. This is a square and then this is a square. A square is just an element to a power 2. So this is a power 2 and then b power 2. Then difference means subtraction. So there is a subtraction. So this makes it a difference of two squares. Wonderful. Now if it is a difference of two squares, how can we simplify this? Algebra has it that a squared minus b squared is the same as a minus b, yes, into a plus b. So can you note this? A minus b into a plus b. So this is the simplification of the difference of two squares. So our factorization is going to base on this concept for this topic of tonight. So let us get a first very example. Assuming somebody tells you to factorize the following. So this is example 1. So somebody is telling you factorize the following. So hope now you know the meaning of the word factorization. If you don't know the meaning of the word factorization, then go back to the preamble where we started the topic, get to know the background of the topic from the book of Al-Jabal, that is algebra book, and then see how far we have reached. You now move at the same pace with us. So factorize the following, assuming somebody gives you a number like x squared minus 16. Yes, people are asking, is this a difference of two squares? We shall see how it becomes a difference of two squares. Then part B, assuming I have, for example, a number like p squared maybe minus 64. Yes. And then part C, assuming somebody brings a number in terms of, assuming it is 121 maybe minus y squared, for example. So people are asking, these differences of two squares, let us watch and see. Okay. Now, here we are. Solution, Mr. Examiner, sir. Solution. Let's start with part A of the question. Let's cause a correct change and borrowing the laws and principles governing the topic. So, the law here or the principle is difference of two squares. And should be in position to recognize that, because examiners will not always tell you that a number has come from a difference of two squares. So I have x squared minus 16. I'll extract it and put it into my workspace. X squared minus 16, Mr. Examiner, sir, is equal to, now once I've realized that there is a difference, automatically this has also to bring a difference for you to apply the difference of two squares. So how can 16 bring a square? Tell me. Oh, people are telling me that that is a 4 squared. Wonderful. So this is the same as x squared minus 4 squared. There's nothing much here we have changed, because a 4 squared is the same as 16. Wonderful. So how can we simplify this? Then we tell the examiner that compare from a squared minus b squared, which is a minus b, into a plus b. Good. CF, I told you, means compare from in our calculations, not Carol's phrase. It is compare from. Wonderful. Now, which means that our x squared minus 4 squared is going to be taken in the form a and b. So x is going to become a, and then 4 is going to become b. The formula to substitute in is here, the difference of 2 squared. So this simplifies as x minus 4, yes, tell me, into exactly x plus 4. Wonderful. So therefore, the original expression was x squared minus 16, which is now equivalent to x minus 4 into x plus 4. Yes, we have simplified our expression into simpler parts. We have broken it into the parts. That is from the definition of factorization. Very wonderful. Let us go to another part, very, very fast. So another part, I'm going to hope I can remove this, hope I can remove that. So people, you need just to take a screenshot or pause. If you're watching this on DVD, take this work into your exercise book. So let us move to another part. The examiner is talking about a p squared minus 64. Good. So part B, Mr. Examiner, sir, you have given me p squared minus 64. So a good mathematician should be observant to see that this question has some knowledge of difference of two squares. I already have one square. I have a difference, that is a minus. Then how can we simplify 64? So dear viewers, can you use the methods of factorization, prime factorization, or factor tree to see how to simplify 64 to bring it in terms of a base and then a square? Oh, people are telling me that this is 8 squared. Wonderful. So 64 is 8 squared. So we have a p squared minus 8 squared. Indeed, we have now made it in form of a difference of 2 squares, which is our subtopic tonight. So we tell the examiner, Mr. Examiner, sir, compare from the original expression a squared minus b squared, which is the same as a minus b, into a plus b. Wonderful. What about our b, p squared minus 8 squared? And this will become now, the value of a has become p, the value of b has become 8. Substitute into the original formula. So this is the same as, exactly p minus 8. Wonderful. Then into p plus 8. Marvelous. This is very interesting. So much interesting. That's where we are. Let us move to the last very part. But we can conclude here and say that therefore, the original expression, the p squared minus 64, Mr. Examiner, sir, is the same as p minus 8, then into a p plus 8. Wonderful. Marvelous. Math is always very simple. Very simple. If at all you know the principles or the laws governing that particular topic. Now let us move to part C of our example. Part C is 121 minus y squared. So we can transfer it into our workspace. 121 minus y squared. So this is going to be still by observation. I've already seen a difference. I've seen a square on y. What about 121? Can I make any numerical, numerical applications, numerical operations, arithmetic operation to express 121 in terms of a base and a square? Oh, people are now going to ask how to do that. Get the square root of 120. Is it square root? Oh, yes, square root of 121. That is the biggest trick. Here we got the square root of 64. If you don't want to pass through the ladder method, or what we call the factor tree to get the factors, and then finally group them into pairs or halfway them and give them powers. So the square root of 121 is going to be 11. Good, because people know that the square root of 100 is 10. 10 squared is 100. 11 squared is 121. So instead of writing 121, we can write 11 squared. Wonderful. So this is the same as 11 squared minus y squared. This time around, we are starting with an integer, and then the unknown comes in later. Wonderful. So we come and say, Mr. Examiner, sir, this is already in form of a difference of two squares, which is our topic tonight. But what does the difference of two squares say? Get a, subtract of b, then a, add b. So bring it here and tell the examiner, Mr. Examiner, sir, then compare from a squared minus b squared, which is equivalent to a minus b, then into a plus b. Wonderful. So this implies that, Mr. Examiner, sir, our 11 squared minus y squared is the same as 11 minus y, yes, then into exactly 11 plus y. Wonderful. So therefore, Mr. Examiner, sir, the given expression 121 minus y squared is equal to 11 minus y, brackets, then into 11 plus y. Very, very wonderful. So this is a very humble beginning as far as difference of two squares are concerned. Immediately after this short break, as we are taking lunch and some of you are going to take a break, we are coming back with more examples. Very, very many examples. Teacher's Light is your teacher tonight. Stay tuned. Yes, dear viewers, we'll be back from the break. Yes, we are still proceeding. We have gone now to example 2. Example 2 is telling us to factorize each of the following. So x squared minus 36y squared is our first very question. So we can come here and say, Mr. Examiner, sir, this is our solution. So in the solution, we extract the examination question from the examination paper into our workspace. So minus 36y squared. So this is what we have. So what can I see? Oh, from inspection, the first difference is here. I mean, the square is here, the difference is there. Then another square, oh, is not complete. I'm seeing y squared, but again attached to 36. Yet I cannot factorize out 36 remaining with x squared minus y squared. So what does that call for? Then we try to get the square root of 36. Exactly, it is there, and it is 6, which means 6 squared is 36. So we can go and simplify this. I told you that mathematics is all about causing a correct change on a number without focusing at the answer. The answer will come out on its own. So in this kind of arrangement, we shall have x squared minus 6 squared y squared. But the difference of two squares is talking of two parts. This part and that part. But here I'm seeing three parts. This, and that. But now this can be treated as one part. 6y can be enclosed in brackets. And then one square. Because I'm seeing a square. Exactly. So I'll go and say that, Mr. Examiner, sir, this is the same as x squared minus 6y brackets squared. Wonderful. So we have now come to the format of the difference of two squares. That is x squared minus b squared. Exactly, which is simplified as a minus b, a plus b. So we have it here. So I can go and tell the examiner that this implies that my x squared minus 6y brackets squared can be simplified in the difference of two square format. That is x minus 6y, good, into x plus 6y. So therefore, the whole original expression, our x squared minus 36y squared, is the same as x minus 6y brackets into x plus 6y. So that is our solution. Very interesting. Very, very interesting. Now let us go and talk about part B. Part B. So part B looks a little bit complex, but it is not. It's not complex at all. Let us go and see its solution. So for part B, the examiner is talking of x minus 2 brackets squared, okay, then minus a 49. So let us go and simplify this. I've already seen one part treated as a square. That is x minus 2. The difference is there. But 49 is not a square. What should I think about? I need to think about square root. Square root of 49, it is a 7, which means opposite of square root is a square. So 7 squared will take us to 49. So we can express 49 in terms of a square as 7 squared. So this will now be x minus 2 squared, then minus 7 squared. Wonderful, wonderful. So this now can be simplified in form of a difference of 2 squared. How? This is a minus b, okay, minus b, that is the first bracket. Have you seen? I'm treating x minus 2 as a, yeah? As a, and I'm treating 7 as b. So a minus b, so the whole x minus 2, then minus 7. Have you seen? Then also we have, in 2 brackets, a minus b, which is x minus 2, then plus 7. Good. So we can even remove these inner brackets. We can remove these inner brackets and then simplify at once. We simplify at once. The math is very, very interesting. Very, very enjoyable. So from here you can do some algebraic simplifications. Yes, of numbers. That is a negative 2 minus 7. That is a negative, exactly a negative 9. So x minus 9 brackets, then minus 2 plus 7, automatically that gives you a minus, oh, it is a positive, positive 5. So x plus 5, x plus 5. So therefore, our x minus 2 squared minus 49 is going to simplify to that value, to that particular value. Very wonderful. Now let us go and also simplify part C of our question. So part C is saying simplify 5a squared minus 45. Very wonderful. So how are we going to deal with this? I'm seeing 5 cannot be expressed in terms of a square. So this takes us to the preamble, to the very beginning of our concept of factorization. We recognize the common factor and pull it out. So 5 is a common factor, is a factor of 5 itself and then 45. So it can be pulled out. Yes, so remove a 5. And then what remains inside here is obtained by getting what is out divided through by this individual part. So a squared divided through by 5, meaning 5a squared divided through by 5, what do you get? I remain with a squared, so I will remain here with a squared minus 45 divided by 5. Oh, I'm remaining with a 9. Oh, we are progressing slowly by slowly. So that's how far we have reached. But now a 9 can be expressed in terms of a square simply because I've seen a squared, which means 9 can be expressed in terms of a square. So think about the square root of 9. That is 3. So the opposite of square root is square. So 3 squared will give me 9. Wonderful. So this is the same as a 5 into a squared minus 3 squared. Beautiful. Then from this kind of arrangement, I can proceed, okay, to express this as a difference of 2 squared. So this will now become a 5 into a minus 3, then into a plus 3. Very, very interesting. So what can we observe here? We can prove out our answers. Go and expand this. I told you the opposite of factorization is expansion. Try to expand this expression. you'll come back to the original expression. The same applies to these other answers. Try to expand them. If you know how to expand, you'll come back to our original expression. The same applies to this. So, we are coming back with example 3. What you need to do is to give yourself a lot of, playing this work again. If you are recording me, or if you are watching this as a recorded DVD. So, immediately after a break, we are coming back with more and more examples. Stay tuned. Yes, dear viewers, we'll be back from that break. Hope you've enjoyed the break. Let us still move to example 3. So the language of the examiner has changed here. The examiner is telling us to simplify as far as possible. Simplify as far as possible. So a simplification, yes, is going to be done with some principles followed. So the first principle, or the principle we are looking at here, is the difference of two squares. So in this kind of arrangement, let us go and start. We have a 63 minus 7x squared. Let us start with that. Okay, I'm putting it here. In the first solutions, let our solution be here. You need to be neat. Present your work neatly. Let equal signs flow in one order to attract the attention of the examiner. So we have a 63 for part A. 63 minus 7x squared. By observation, there is no way we can make 63 a square. Yes, by observation, there is no way we can make it a square. It's not a square number. It cannot produce what is square number. It cannot be produced by a square number. 7, there is no way we can make it a square. What does this imply? It implies there is a common factor which we need to first remove out in the process of factorization. The initial factorization, where we started from. So in this kind of arrangement, you realize that if I divide 63 by 7, I'll get something. 63 is divisible by 7. Then ask yourself, what is 63 divided by 7? Oh, my students in class are telling me 9. Exactly, so that is 9. So I can factorize out 9. It is a 7. Not 9, but 7. So 7 becomes a factor. It can divide itself, and it is dividing a 63. So 7, yes, come out. So 63 divided by 7, I'm getting a 9. Minus, 7 is already out because 7 divided by 7 is 1. So I'm remaining with x squared. Good. That is our start. Now let us put the focus on the brackets. Can they produce a difference of two squares? The answer is yes. How? A 9 can be expressed in terms of a 3 power 2. Wonderful. So we go and write that. So it is still 7 out, 3 power 2 minus x squared. Good. Now, when you inspect the brackets, they have moved to our format. The point of concern today, what we are talking about today, and that is a squared minus b squared. Very wonderful. So we have a minus b, a plus b as our simplification format. So can we simplify this? So this will now become a 7 into 3 minus x, good, then into 3 plus x. Wonderful. So those are our solution or simplification for part A. Let us now move to part B. Reading through the question is part of interpreting the question. So can everybody read part B? 3 brackets x minus y brackets squared minus 12. Good. So that is part B. Part B, 3 brackets x minus y brackets squared minus 12. Good. So when I look at this and what we are talking about, there is no way we can bring in the difference of two squares directly. which means there is some factorization which is needed at first. So can we factorize first? Yes. Recognize a common factor. And the common factor is 3. Good. Because a 3 will divide 12 into 4. And a 3 will divide itself into 1. So we can go and send this examiner side. And this is the same as saying 3, okay, brackets. Put bigger brackets. Factorize it out. So you remain with x minus y as one part. And then you remain with a 4. How have you remained with a 4? It's because you have got this common factor. You have divided 12 by the common factor, giving you a 4. And you have also gotten a 3 divided through by the common factor, which is 3, to get a 1. That's why the 3 is no longer appearing on the small brackets. But now when we inspect these big brackets, these bigger brackets, you can see that there is a first square and a difference. But 4 is not a square. But it is a square number. It can be made a square. Oh, wonderful. So 4 into a square number, in terms of a square, what do we get? Oh, it is 2 squared. Very, very good. So we shall say, since this space is not enough, allow me distort the order of our equal signs. So I will say that all of this is now becoming 3 brackets into x minus y squared minus 2 squared. So inside the bigger brackets, we are having a difference of 2 squares, which can be simplified. So this is the same, 3, okay, into x minus y minus 2. That is the first. We are treating this as one item, one element. Then minus the one element we are talking about, okay? Then, is it minus? There is no minus. Into another bracket. X minus y into x plus y. Or a minus b into a plus b. So another bracket is going to be x minus y plus 2. However, this needs more simplification. So we can still keep our 3 and our bigger brackets. Oh, is there any other simplification? No, these are not like terms. You don't have like term. So this is the final expression. So you can come here and say that Mr. Examiner said therefore 3 into x minus y bracket square minus 12 will give you that kind of arrangement. Very wonderful. So let us move to part C of our question. Part C, can somebody read for us part C? Oh, I'm hearing people are reading part C as 2a cubed b minus 8ab cubed. Wonderful. So part C, 2a cubed b minus 8ab cubed. This is going to be by inspection. What can you see? I'm saying 2 is appearing here, and 2 can appear in 8, which means 2 is a common factor. Hey, 2 can divide 8 without leaving a remainder. Good. I can see a cubed, a power 1, which means the one with the smaller power becomes a factor. Yes, because a. Then the one with the smaller factor, power becomes a factor. So a power 1 is the factor. So now we have 2a. Good. Then I'm seeing b power 1, b power 3, which means the one with the smaller power is a factor, and that is a b power 1. Good. So from that kind of arrangement, we have now got a common factor as 2ab brackets. Now what remains into these brackets? We are going to get our common factor, bring it as a divisor of all these parts. So we are getting the 2a cubed b divided by 2a. We need side work for that, for people to observe what is taking place. So allow me rub off this, hope you understood it, or you can make a screenshot and paste it into your work. So we can proceed. So allow me to borrow this part slowly. Okay. So to get what remains here, we shall get the original part divided through by the common factor, 2ab. So you're going to realize this, that a 2 and 2 is cancelling. A, 1 by a, it remains a power 2 from the laws of indices. That is second law of indices. When I'm dividing elements to the same base. By B once, by B once. So the overall thing remains with A squared. So here we shall remain with A squared. Then our minus is there. Then let us go and check also if the second part is divided through by our suspected factor. So our factor is 2AB, the part is 8AB cubed. So let us divide through by a 2AB. Wonderful. So we are going to realize that 2 divided by 2 is 1, and then 8 divided by 2 is a 4. Good. Then a power 1, they will divide to get 1. Then b power 1, okay, and then b power 3. From the second law of indices, we shall get a b squared. What we are saying is this: if you have b power 3, divide through by b power 1. This is the same as raising to one base, subtract the powers. We talked about this in the concept of indices. So this now will become a b power 3 minus 1 is 2. That's why we are remaining with a b squared. Not forgetting the 4, which we got from 8 over 2. So that is the second part. We can bring it here and say 4b squared, Mr. Examiner sir. That is so interesting, so wonderful. Now let us go and see what else can we change on this. We can change a 4 in terms of the square. So 4 is the same as 2 squared. So let us go and do that. So this is going to be a 2ab into a squared minus 2 squared b squared. That is our stand. But now on inspection, the bracket is becoming a difference of 2 squares. If at all this was 1